Probability IB questions, problem 6. In a school, the probability that a student takes chemistry is 0.7. The probability that a student takes English is 0.4. The probability of a student not taking either course is 0.18. Believe it or not, those 3 sentences gave us everything that we need to show this information on a Venn diagram. The Venn diagram that they give you on the worksheet has this labeled as A and this one labeled as B. I put it as C and E, C to signify chemistry, E to signify English. From our knowledge, we know that A plus B is going to be equal to everything within C, so the probability of choosing C. They gave us the probability of choosing C as 0.17, so we know that 0.17 is equal to A plus B. We also know that English is everything within this red circle. So it's B plus C. So they gave us the probability that a student takes English is 0.4, so 4/10, is equal to B plus C. We also are given a piece of information that we can certainly use to our benefit. At first, it doesn't seem like it. It just tells us that the probability of a student not taking either course is 0.18, but we can use that right over here to find the complement. So the probability that a student is taking a course, either chemistry, English, or both, we find that to be 82 hundredths. 1 minus 18 hundredths equals 82 hundredths. So 1 minus 0.18 equals 0.82. This is going to be the probability of a student in chemistry or English, which we can see here, A plus B plus C. Got that right here. We have all the information that we need in order to solve for A, B, and C. We have 3 equations, this top one, this middle one, and this bottom one here. So we'll call it the blue, the green, and the pink equations. And we can just use substitution. We see that up here that we have a number for A plus B. We can plug that in right here to our pink equation and say 7/10 plus C is equal to 82 hundredths. 0.7 plus C is equal to 0.82. Solve for C. Now we know that C is 12 hundredths. Then we can use that information and plug it into our green equation right down here. So now we have 4/10 equals B plus 12 hundredths. Pretty cool. We can just solve for B. B is 28 hundredths, 0.28. And then we can use that information, either plug it into the pink equation or pop back up here to the blue equation and solve for A. We just fill those into the Venn diagram. It's as easy as that. Just signifying these spaces as A, B, and C, using what they give us in the problem and solving for A, B, and C. Now in B it says determine whether the courses of English and chemistry are independent and show this mathematically. Well, we are given, I believe it's in section J of chapter 16, the probability chapter, we're given that independent events, again, which we talked about, aren't dependent on each other. That's the definition of independent. But we also know something pretty fun, that the probability of A and B, remember that this right here is our mathematical symbol and probability for and. So A and B is equal to the probability of A times the probability of B. Well, in our case, we're looking at C and E, so we're saying the probability of C and E is equal to the probability of C times the probability of E. So what we're focusing on here is we're trying to see if this centerpiece that I just unfortunately colored pink, it's a little too dark. Alright, so this middle section here, this 28 hundredths, we want to see if the probability of C times the probability of E is equal to that. Well, we know that the probability of C, which we were given in the problem, is 7/10. We know that the probability of E, student taking English, is 4/10. So we multiply these together. That's what we're doing down here. And what do you know? We find that it is 28 hundredths, 0.28. And so yes, these events are independent. We showed that what we found here as being our intersection between C and E is indeed equal to the probability of C times the probability of E.